In this lesson, we'll be doing the corrections for the Limpopo paper, which was written on the 12th of March 2023. So, the first question was a linear equation. This was simple. So we're given 2 minus 3x. So it's 2 minus 3x is equal to x minus 6. So it's equal to x minus 6. So what you have to do here is to group like terms, right? Is 2 plus 6 is equal to x plus 3x. So 2 plus 6 is equal to 8, and x plus 3x is equal to 4x. Dividing both sides by 4, we get our x is equal to 2. And that is the answer for the first one. X is equal to 2. So let us do the second one. The second one is still a quadratic equation. Okay, so we're going to solve it. 6x squared plus, that's minus x, right? Minus x minus 15 is equal to 0. So you could have solved this using a quadratic formula, but I'm going to factorize it. So if you factorize it, you must find that at the end you must have the factors. Okay, let's just do it. So here we're going to have 3 and 2, right? And this side, I believe we're going to have 3 times 5. So this method, you place the factors of 6 on this side and the factors of 15 on this side. And then you're going to look for if this can give you the middle term when you multiply diagonally. Therefore, you take the factors. So if you can say 3 times 3 is 9, 2 times 5 is 10, and 9 and 10 can give us 1. So therefore, we can take the factors. The larger factors of 3 and 5 must take the negative sign, that is the coefficient of x. So this will be negative and this will be positive. If you don't understand it, then I advise you to use the quadratic formula, since it's always safe. Okay, so this will be our factors for this problem, and 3x minus 5 is equal to 0, or 2x plus 3 is equal to 0. So we can take the negative 5 to the other side, such that 3x is equal to 5, or 2x is equal to negative 3. So dividing both sides by 3, x is equal to 5 over 3, and this side we must say or, don't say and, say or, right? Therefore this side we divide both sides by 2, and our answer is negative 3 over 2. And that is all for this problem. So here we can say that our x is equal to what? Our x equal to negative 5. No, it's positive. So it's positive 5 over 3. Okay, it's 5 over 3, or negative 3 over 2. And those are our solutions for that problem. We are moving to the next one, and that is a quadratic formula type of problem. So, right, so how do you know you're supposed to use the quadratic formula? They told you to round your answer to 2 decimal points, and make sure you round your answer to 2 decimal points, because if you round to 3, your answer is wrong. So it says 3x. Okay, so it says 3x squared plus x minus 5 is equal to 0, and we must apply the quadratic formula. So our value of a here is equal to 3, b is equal to 1, and c equal to minus 5. So the quadratic formula says that x is equal to negative b plus or minus the square root of what? B squared minus 4ac over 2a. Right, so our x is equal to negative b, that's negative 1, plus or minus the square root of what? 1 squared minus 4 times a is 3, and our value of c is negative 5. And we're going to divide everything by 2 times 3. That is the value of a. Then at the end, we must observe that here our x value is equal to 4. Our x value here is equal to 1,14, or our x value is equal to negative 1,47. So make sure you are able to do this, right? And round your answer to 2 decimal places, because they said 2 decimal points, right? Don't round to the number of points which are not required of you, right? So that is all from that question. Now we are moving to 1.1.4, and that is an inequality sign type of problem. So it says x minus 1 squared. X minus 1 squared is more than 9, right? So you can be more creative when working with this problem, right? You must be able to manipulate it, but it's fine. Let's factorize the left side first to make it more simple. So we're going to have x minus 1 times x minus 1 minus 9 is more than 0, right? So what is x times x? It's x squared. X times negative 1 is negative x minus x is negative 2x. And negative 1 times negative 1 is positive 1. Then minus 9 is greater than 0. Therefore, we've got x squared minus 2x. 1 minus 9 is negative 8 and it's more than 0. So we can factorize this, right? By looking for the critical values. This will be x minus 4 and x plus 2. So remember, you can factorize, use the formula, the quadratic formula. So here our critical values are x equal to 4 or x equal to negative 2. And these are the ones which we're going to work with to determine the solution. Remember, that's not the final solution. They didn't ask us to solve for x. We must solve the inequality, right? So we're going to draw a timeline or a number line, however you want to call it, right? So I'm going to use a different color. Okay, so let's draw our number line here. This extends to positive infinity, and this one extends to negative infinity. And we're going to put our two critical values in ascending order. This will be negative 2 and this will be 4. We're going to plug a random number between negative infinity and negative 2. It can be something like a negative 5, right? And where are we plugging it? Remember, we've got this expression which we've solved right now. The one which gave us these critical values. It's x plus 4. I shouldn't have erased that one. X plus 4. X is plus 4. X minus 4, right? Forgot that one. It's x minus 4. So it's x minus 4 multiplied by what? X plus 2 must be greater than 0. So we're going to plug a random number between negative infinity and negative 2. So we can plug a negative 5. If we plug a negative 5 in this expression, do we get a positive or a negative number? We must observe that we've got a positive one. So we're going to have a positive sign here, right? And if we plug a number between negative 2 and 4, let's say 0, we're going to have 0 minus 4 is negative 4 multiplied by 0 plus 2, that is positive 2. And the answer there will be negative. So you're going to have a negative sign here. And same applies to a number between 4 and positive infinity. We can plug 7. So if you plug 7 or in any number more than 4, you get positive here. So what does this mean? This tells us that we will find the solutions for the positive inequality in the range where x is less than negative 2. Right. Don't include the boundaries. So you must say that x is less than negative 2. Right? Okay. So, don't know what is happening with this. So x is less than negative 2. x is less than negative 2 or x is more than 4, but we don't include the boundaries, and I'm sorry for that. So that is the solution for 1.1.4, right? So now we're going to move to 1.1.5, and that is a third equation. So we're given that the square root of 2 minus 7x is equal to 2 minus x, right? So let's see. The first step in solving this type of questions is to square both sides. So let's square both sides of the square root of 2 minus 7x. We square both sides. Even this side we apply the square root. 2 minus x all squared. So what is the square root of a number is equal to the number inside the square root. So this will be 2 minus 7x is equal to, if we factorize this, we must end up with 4 minus 4x plus x squared. Remember, you have to expand the bracket, and then you multiply 2 squared is 4. 2 times negative x, negative 2x, times 2 is negative 4x, then plus x squared. Let's add like terms. 0 will be equal to what? X squared has got no like term, so it's x squared. Negative 4x will be added to 7x. Remember, the negative 7x will go to the right side. Then we're going to have negative 4x plus 7x, and we're going to have positive 4 minus 2. Then at the end, 0 is equal to x squared plus 3x plus 2. Remember, with equations involving a set, you must test the answers to see if they satisfy the left hand side is equal to the right hand side. If not, therefore, you have to reject that solution. But in this lesson, I'm not going to check them. I'm going to leave it to you to check them and tell me in the comment section if they do really match. If they don't, then reject one. So our values here are negative 2 and negative 1, and these are the solutions to this problem. So remember, check the one which matches and the one that doesn't, and write in the comment section. So we are done with that one, and we are going to move to the next one. That is the last one for this slide, but not for this lesson. There are still other two in the next slide. Oh, that is the last one for this slide. Sorry. Okay, so now let's move. We are now here on simultaneous equation. Right, so we are given this equation, x minus 2y equal to 1, right? So we can call that equation 1 and call this one equation 2. So notice that we can obtain equation number 3 from equation number 1 by making x the subject of the formula, right? So we can write x is equal to 1 plus 2y. We just have to move the negative 2y to the right side, and it changes the sign, and this gives us equation number 3. So let's plug equation number 3 in equation number 2. Right, wherever we see x, we're going to plug 1 plus 2y. So what is x squared will be 1 plus 2y squared, right? Minus 2, let's say is negative 2xy, right? So we know that negative 2xy is the same as negative 2yx. So we can just put y here and then x here. And our x is 1 plus 2y. I wrote it in this form because we know that ABC is the same as CBA is the same as BAC. However way you can manipulate the variables, still they mean the same thing, right? So that is plus y squared equal to 9. So what is 1 squared? That gives you 1. 1 times 2y, that gives you positive 2y. 1 times 2y again, still positive 2y. And 2y squared, that gives you 4y squared, right? So that's 4y squared. Negative 2 times y, now we are here. Negative 2 times 1 gives you negative 2y. And negative 2y times 2y gives you negative 4y squared. And then, okay, that is squared there. Plus y squared equal to 9. So we can add like terms, right? Note that the 4y squared cancels with the negative y squared, right? And we can cancel one of the negative 2y's with this one, right? And what else do we have here? Let's see. Seems like there's nothing else that's left, right? Yeah, nothing else. So our answer there will now be, we're left with y squared plus 2y plus 1 minus 9 equal to 0. Therefore, y squared plus 2y, 1 minus 9 is negative 8, and we can equate that to 0. And we have solved this equation in the last video, in the last example. So it's very similar to the one we've solved, whereby the factors were y, and this time we've got plus 4 and minus 2, and our y value is equal to negative 4, or our y value is equal to 2. Notice how I say or and not and, right? So we're going to determine the x value that corresponds to each y value here. So our expression for x is given as x equal to 1 plus 2y. It's this one here. Okay, so it's this one here. X equal to 1 plus 2y. So we're going to write it here. And x is equal to 1 plus 2y. So let's find the value of x that matches with the value of y equal to negative 4. So if we plug y equal to negative 4, what do we get? And that's what we're looking for. X equal to 1 plus 2 times negative 4. And the answer is 1 minus 8, that is negative 7. If we plug y is equal to 2, what do we get? We get that x is equal to 1 plus 2 times 2, and our answer is 5. This means that when the value of x is negative 7, the value of y is minus 4. And if the value of x is, the value of x is 5, the value of y is 2. And these are the solutions for this simultaneous equation problem. It requires a lot of thinking, right? And there's one thing again which requires a lot of thinking, and mostly these questions on 1.3, they don't require you to follow a specific formula or cram them. You must just apply algebraic manipulation to be able to solve them. So we're given a problem here. They tell us that 12 to the power of x plus 1 is equal to what? Is equal to 36 multiplied by 6 to the power of x. And we must show that it can be written as 2 to the power of x equal to 3. So we must solve there, of course, right? So we can see that we've got 12 on the left side, and we must write the right side at least having 12, right? Or on the left side here, we can see that we only have x, right, as the exponent and not x plus 1. So how can we come with that thing? Well, we can change 36 and write it in terms of 12. So 12 to the power of x plus 1 is the same as 3 times 12, right? That's 3 times 12 times 6 to the power of x. And we can divide both sides by 12 from here. We know that it's going to subtract the exponent there. So we divide both sides by 12. Divide both sides by 12. And it's 12 to the power of 1, right? So this, on the right side, 12 will cancel 12. And on the left side, we're going to have what? 12 to the power of x plus 1 minus 1. Remember, you are dividing the same base, you must subtract the exponents. And on the right side, you are only left with 3 times 6 to the power of x. So these two will cancel out, and we're only left with 12 to the power of x. So 12 to the x is equal to 3 times 6 to the x. Let's write 12 in terms of 6, right? So 12 in terms of its two prime factors can be what? Can be 6 times 2. So 6 times 2 all to the power of x is equal to 3 times 6 to the power of x. Remember the rule which says that if we've got a, b to the power of n is the same as a to the power of n times b to the power of n. I'm going to apply this rule, and let me erase here. I'll erase from here. Okay, so what we can do here, we can distribute the exponent x to each term inside the bracket, only if we are multiplying. So from here, we have got 6 to the power of x. Okay. We have 6 to the power of x times 2 to the power of x is equal to 3 times 6 to the power of x, right? Therefore, from this point, I can cancel out the 6 to the power of x, meaning I divide both sides by this, and they fall off. Now our final answer is 2 to the power of x equal to 3. And there I have proved it. You see, that was worth it. I think it was for 3 marks. So, don't lose hope. In the exam, if you see it's tough for you, skip it a bit and then come back to it later. Don't leave the stone unturned, right? So, from this expression now, we must solve for x, right? So, solve for x and correct to 2 decimal places, not 3, not 1, right? So, it's always good to follow instructions. When they say round off to what? Round off to 2 decimal places. Make sure that your answer is indeed rounded to 2 decimal places. So, what are we going to do here? We know that x will become the left side. We've done logs, right? So it can be written as x is equal to the logarithm. The base will be 2. The number will be 3. And at the end of the day, we can find that our x is equal to 1,58. 1,58. And that is to 2 decimal places. And I hope this lesson was useful. Make sure you do corrections. Remember, failure is the next step to succeed. Thank you for watching.